So first chapter is antiderivatives. Okay, so here we go. Let's big F be a function such that big F prime of x equals small f of x. Okay, so basically I have two functions here, one big F and one small f, and small f is the derivative of big F. Okay, so we say that, so obviously like you did in count 1, small f is the, so change color here, derivative of big F. Okay, and the symbol for that is a little prime. Okay, or if you want the Leibniz notation, okay, so we write so either big F prime of x is equal to, or you could write also d big F of x dx. You've seen both notations, I'm sure, equals small f of x. Okay, that's what you write. Okay, that's notation. And big F is also the opposite. So big F is an antiderivative of small f. Okay, I'll continue up here. Okay, and I'm going to write down the notation, just like I wrote the notation here to find the derivative of either prime or d dx. So for the antiderivative, so we write so big F is equal to, so how do I write this? So there's a big symbol that you've seen probably. It's this. Okay, so you find antiderivative. So all this symbol, this sort of weird s and dx, is the equivalent of the prime. Okay, going derivative, going this way, this is a more complicated symbol. Okay, a two-piece symbol.
Sir?
Yep.
If x dx is, that just means that derivative of f? That's it?
Excuse me, if what? Oh, this one here? This?
No, like the other one?
Here?
Yeah.
Okay.
Fx dx just means the derivative of fx, like the big F?
The small f is the derivative of the big F.
Uh-huh.
Big F is the antiderivative of this.
Okay. Okay.
So go the other way. Okay. So just one thing I want you guys to notice is that I wrote, we say that's a v derivative. And here I didn't say that it's the antiderivative. I wrote it's an antiderivative. So I'm hinting you that there might be more than one. Okay. So you don't, it's not necessary that you just have one antiderivative per function. Okay? Okay, so you have to again be very alert and see these little hints here. Okay, so an antiderivative is important because there might be more than one.
Is there supposed to be a prime on when you say f prime of x equals d of f of x over dx equals f prime of x?
This here?
Or
this?
Yeah.
No, small f. There's two functions, big F, small f.
Oh, okay.
Okay. So I'm going to give you an example. Okay. So for example, find an antiderivative of, so let's say f of x. I'm going to start with a very, very easy one. Cosine x. Okay, so remember, I'm going the other way around. Okay, the other way. So I'm asking, what should I derive to get cos x?
Sin x.
Sin x, very good. So the answer would be so I'm going to write like this. So the antiderivative of cos x dx, right? The antiderivative of cos x is equal to, so you told me sin x. Perfect. Why? Because if I derive sin x, I get cos x. Questions? Okay, the only problem is that, how about this one? Oh, could you see, or it cut off?
It cut off.
Cut off, sorry.
Is it negative cos x?
No, it's cos x.
Oh, okay.
The derivative of sine is cos. Okay, so it's a bit tricky. Okay, I mean, I was planning when I was teaching Cal last semester to start antiderivatives with the class, but then I said you're gonna get mixed up with the two sides, so I just dropped it. We're doing it now. So sine x. So I could do also plus 7. This is also good because if I derive sine x plus 7, right? 7 is a constant; it will be 0. So it's still going to be the derivative of this will still be cos x. Do you understand this?
Yes.
Yes.
Okay, so that's why I'm saying an antiderivative, because as you see, there's millions of them. Okay, so what I could do here is I could just, that's what we're going to do, and we're always going to put a constant here, plus any constant. So all these functions here that are sine of x plus a constant will have a derivative of cos x. Is this clear? So, okay, so if you want to maybe visualize it geometrically, I'll try. Okay, so all the functions that have this derivative of cos x are these ones. So first of all, there's the simple sine function. Okay, and so on. But also, any translation of this, vertical translation of this function will also have same slope everywhere, right? This one also. This one also. Okay. All these functions, right? They have, if you take the slope at any place, it's the same slope everywhere. For every x, you have the same slope, which is going to be cos x. Is this okay?
Yeah.
Okay. So at this point, what we have to do, okay, so now that you understand the idea, what the game is, it's a little game, okay? Just guess, can you guess what should I derive to get cos x? And I'm going to give you a few more, and can you guess what should I derive? It's like a little riddle. So I just have to maybe refresh your memory on all the derivatives that we did last semester. Okay, so the derivative of tan is secant squared, derivative of secant is secant tangent, and so on, so that when you see a secant tangent, right away you know that the antiderivative is secant, and so on. Okay, so I'm going to do, I'm going to rewrite all the derivatives. Okay, so that you have them in one screenshot. Okay, so you can always refer to them at first until you know them by heart, which hopefully you will. Questions?
Sir, I have a question.
Yeah.
Are we gonna have like antiderivative rules like we did for derivatives? Or we just have to refer to derivatives and guess?
You're going to have, first of all, the basic is you're going to have to refer, you have to know that by heart all your derivatives. And then you're going to have some rules, like you mean the product rule, quotient rule, chain, all these stuff. Yeah?
Yeah.
Yeah, there's the equivalent for, but it's more complicated. Okay, there's more, it's not as obvious like you see a derivative, you say, oh, there's a product rule. No, it's not as easy as that. It's going to be a few techniques to integrate to find the antiderivative. And you're going to have to identify which technique to use, and it's not always easy. Okay, even a lot of time I look at an integral and I have to scratch my head and say, okay, how do I do this one? Okay, it's not, it's a much more difficult exercise, you'll see. Okay, but at least if you end up, you work and end up with this integral after all your steps, well, yeah, you should know that this is fine. Okay, so this you can't hesitate here.
Okay, thank you.
Let's go. Okay, so here is the reminder. So here we go. Let's start with the trig functions. So sine x prime is cos x. So this means that the antiderivative of cos x is equal to sine x plus. Okay, that's what we just did. The derivative of cos x is, what is it?
Minus sine x.
Negative sine x. And so the antiderivative of sine x will be what?
Minus sine x plus c.
Minus cos x plus c. Right? If you derive cos, you get minus sine.
Yes, thank you.
Okay, so if you derive minus cos, you'll get sine. Okay, so it's tricky. Okay, let's go. Let's continue. The antiderivative of, the derivative of tangent, the derivative of cotangent, derivative of secant, the derivative of cosecant. So all these. Okay, so the derivative of tangent was, if you remember, secant squared x. Derivative of cotangent was negative cosecant squared x. The derivative of secant is secant times tangent. And the derivative of cosecant is negative cosecant times cotangent. Okay, and I'm going to write the equivalent antiderivative. So for each one, so the antiderivative of secant squared will be, of course, tangent. The antiderivative of cosecant squared would be what?
Negative minus cotangent.
Very nice. Negative cotangent. The antiderivative of secant times tangent well, this is going to be secant. Don't forget the plus c, right? Forget the plus constant always. And the antiderivative of cosecant x times cotangent x dx is so negative,
Cosecant x.
negative cosecant, right? Don't forget the negative. Okay. Few more. Hope I can fit them here. So e to the x prime is just e to the x. Ln of x prime is 1 over x. Okay, so this means that the antiderivative of e to the x dx is just e to the x plus c. And the antiderivative of 1 over x dx is ln of x plus c. You with me? Okay, the only thing I need to specify here is that ln of x, right, is only defined when x is a positive number. Okay, you cannot have the ln of the negative, so we have to make sure that this is positive, so I'm going to put an absolute value. Okay, that's important. Okay, the antiderivative of 1 over x is ln of the absolute value of x. Okay, here, when you find the derivative, there's no need for an absolute value here because I'm assuming that if they gave me ln of x, then they already specified that x is positive, or else this function makes no sense. If the domain of this function is between 0 not included to 0. So I have to make sure when I do the antiderivative that I only consider the positive arguments of the line. Okay, so these are all the basic derivatives, basic and basic integrals. So the only thing remaining now is the inverse trig ones. Okay, so I'm going to erase and show you the inverse trig ones. So let's do the inverse trig ones. So these ones are a little more complicated to remember. So arc sine of x prime, you remember this? So 1 over the square roots of 1 minus x squared. Okay, so this means that the antiderivative of 1 over square root of 1 minus x2 dx is equal to the arc sine of x plus. Okay. Then the arc tangent, and then the arc secant. Okay, the arc tangent was 1 over 1 plus x2, arc secant 1 over square x root of x2 minus 1.
Oh, sir?
Yep.
The one for arc cosine is the same as arc sine, right?
Except that it's with a negative. Exactly.
Okay.
Okay. So basically, if there was a negative here, you would put arc sine, or if you want, you could just do negative arc sine. right? Negative, so this is equal to arc sine or negative arc cosine. They both have the same derivative. Okay, arc sine and negative arc cosine have the same derivative. So I'm just doing these three. Okay, because I have no space, but that's the idea. Okay, so integral, and here I will have 1 over 1 plus x2 dx, 1 over x root x minus 1 dx. So I'm just repeating what we did in calculus 1, basically. Okay, so this is arc tan x of c and arc cosecant, arc secant. Oh, arc secant x plus questions?
So, sir, basically on the right is like the antiderivative, and on the left is the derivative.
Exactly. So this is the antiderivative. So basically it's the other way, going the other side. If I gave you this, if I gave you 1 over 1 plus x2, right? What should I derive? Well, I should derive arc tan.
Okay, right. Thank you.
Okay, so let's do a few examples.
Sir?
Yeah.
There's someone in the waiting room.
So, so find the antiderivatives. Okay, so I'm already going to post after this class a worksheet on finding antiderivatives. Okay, you'll be able to do it already. Okay, so let's start with the first one. So the antiderivative of x2 dx.
2x plus c.
So 2x plus c and c. So if I do the derivative of 2x, what do I get? I think I get 2, no? So that's not good. Remember, what should I derive to get x2?
X cubed over 3 plus c.
Okay. You did the opposite, right? Do you understand what I just said? So it's x3 over 3. Do you get this? Because if you do the derivative of x3, you get 3x2, the 3's will cross out, you get x2. Again. Number 2, the antiderivative of x5 dx.
X6 over 6 plus c.
6 over 6 plus c. Is this clear for everybody? Okay, so this leads us, so I see a pattern here. So it leads us to a first big rule. Okay, so I'm going to write it down here. This is the power rule. And the antiderivative of x power n dx is equal to, can you tell me?
Xn plus 1 over n plus 1.
minus x power n plus 1 over n plus 1 plus, don't forget plus. Okay, so here's our first big rule, and that is the power rule. Put a box around it so that you don't forget it. Okay, so there was a power rule for derivatives. Here's the equivalent power rule for integrals, okay, for antiderivatives. So that's what I did here. X power n, so x power 2. So n plus 1 is 3, n plus 1 is 3. 3, same thing. 5 plus 1 is 6, 5 plus 1 is 6. Clear? Easy? The linear properties of the integral. Okay, the integral is the antiderivative operator. Okay, integral. Okay, so just like when you did the derivative of a sum, it was equal to the sum of the derivatives. Same thing for the integral, okay, for the antiderivative. So first properties is that the antiderivative of, let's say you have two functions, f of x plus g of x dx. Well, you could just do the integral of each one and add it, right? The antiderivative of f of x plus the antiderivative of g of x. Okay, so this is the first linear property. Okay, same thing if it was minus, it would be the same thing. Okay, so if you have the antiderivative of a sum of functions, you could just do the antiderivative of each one. And second is that the antiderivative of, let's say, a constant times a function. What can I do?
Take the constant out.
Take the constant. So it's a times, just like in derivatives. So these are the linear properties of the integral. Okay, so example. So find so the antiderivative of so let me see here, secant times tangent minus 3x squared plus 1 minus e power x.
Secant x minus 3x cubed over 3, which is just x cubed.
So it's equal to secant x minus x cubed.
X cubed minus e to the x plus c.
And the 1 minus the 1.
Becomes x.
Okay, so plus x. And this is minus e to the x, and then plus. Do you understand this?
Yeah.
Sir, can you explain it again?
Sure. Okay. So if I were to do the steps, okay, let me do the steps here. Okay. So from here to here, what happened? So it's equal to. So I have to separate every integral. So it's the integral of secant x secant x tangent x dx plus minus the integral of, so 3x2, so minus 3 the integral of x2 dx, plus the integral of 1 dx, and then minus the integral of e to the x dx. Okay, so I have 1, 2, 3, 4 integrals. Okay, so what should I derive to get secant tangent? Well, it's secant. What should I derive to get x2? We did it before, it's x3 over 3. So the 3's cancel. What should I derive to get 1? It's x. And what should I derive to get e to the x? It's e to the x. 1, 2, 3, 4 terms, 1, 2, 3, 4 terms, plus.
Sir,
Yes?
it doesn't become 4c, right? It's just always c.
Yeah, it's always, you can write 4c, 10c, 100c, who cares? It's just a constant. All the constants you're going to combine it into one constant. Questions?